it wrong and I haven't graded it. All right, y'all ready?
We do a spandex Spider-Man. High spandex? That's you all.
No, because Logan was.
Oh, yeah. Everybody's Saturday Logan.
All right, so we've only got 2 more things and we're done. Today and tomorrow. Function operations, yeah. I thought I did. Did it not go? Function operations.
Does the stuff on Khan Academy
A little bit different.
No, it doesn't teach it.
But you still do.
This is how you do it.
Oh, I got the wrong date by it.
This
This is it. I just forgot to update it. No, it won't, because you can still do the.
But like, what if no, I'm just gonna retain a little bit. You know what is it?
Don't let him in.
Let him in.
Let him in.
Don't let him in.
He's my best friend. Let him in.
Don't let him in.
There's only one.
Okay. No,
So, yeah, I told her the one in the room. She was like, I was like, no, the one in the room. She just said it.
Function operations. Along with the function operations, we're going to talk about combined domains. Okay, that's the new part. Is the combined domain, but the function operations themselves are really easy. It's just the domain part that starts to give us a little bit of a hard time. We're going to do combined domains. Okay. Now that multiplication and division, the hard part's going to come in whenever we do the domain of each one. So here we go. Nothing to it. Oh, and composition. There's a fifth. Nothing to it but to do it. Oh my gosh, why do y'all keep saying
People know
that?
that song.
What is that song from?
It's not from anything. It's a song from like 40 years ago.
All right, so maybe I've got, and I'm just going to define a couple functions here before we start. We'll get some.
Oh, is this the one where you do like 3x minus 1 plus x squared plus x? Like this.
That's composition. We will. Yeah, we will, but not yet. All right, so addition, subtraction, really easy. There's a little bit of a new notation that we use. Instead of just saying f of x plus g of x, we may write it like this. And that's the exact same thing. I defined f and g to start with. So if I ask you to find f plus g, all you're going to do is f plus g. That could not get any easier, right?
That's right.
All right, let's change it just quickly. If I asked you to subtract the two functions, we're going to do the domain. Be careful when you subtract. I just felt like this needed saying here. If I'm subtracting, this is f and this is g, but I'm subtracting everything, right? So be very careful. You subtract everything in f and not just that first term. So this is really going to be x squared plus x minus 3x plus 1. Not as much with combined. Some things go a little funky, but it's a really easy concept. It's really easy.
Oh, that was
All right, so let's talk about domains because this is the new stuff, okay? Combined domain does exactly what it says. It combines the names of the domains of the functions that you started with, okay? So if anything is left out of either one of the ones to start with, I have to leave that out as well. And then once I combine them, I look. So I'm looking at 3 different functions in the domain of all 3 to combine. Now, before we get into that, let's just recap and review back Algebra 2, maybe even prior. What causes restrictions in our domain? If we're talking about functions.
Numbers.
Not being a
What? But what causes restrictions in the domain of a function? Oh my goodness, there's 2 things I told you to always
doesn't
look
go
for in the
to
equation.
Imaginary numbers.
What causes imaginary numbers?
Having a negative inside of a square.
Having a negative under the square root. That's exactly right. One thing that restricts our domain is radicals, because anything under the radical has to stay greater than or equal to 0. That's why if I've got the square root of x, my domain for that one, x has got to be bigger than or equal to 0, so we say it's from 0 to infinity on my domain. Does that make sense? Kind of.
What if it cuts off?
Okay, that's different, but we're talking about just in general things I'm looking for. What else can cause me to have a domain restriction? What you got? Not on, because I can still plug in negatives. That's a great guess, though. What causes something to be undefined? What's
when it has a 0 on it.
when it has a 0? So I'm looking at radicals and I'm talking about fractions. The bottom can never be 0. Okay. So if any of these situations happen, it tells me that I have to leave things out of my domain or I have to restrict my domain. And even though once I combine these functions, that situation may not exist anymore because it existed initially, then I have to include it as a restriction in the combined domain. And I'll show you exactly what I'm talking about. Denominator. Denominator. That's just a continuation of that word.
Oh,
Yeah. Yeah, it's a piecewise word. Yeah. Discontinuity. What are you drawing?
I don't know. Drawing logo.
Let me switch up F and G for you.
No?
No way you wrote that.
What am I doing here?
How are you gonna write about it? I wrote about that effect.
Noah, what you doing right here?
Factor it out. Well, you're multiplying the F and G.
You're multiplying the F and G. That's exactly right. Good job not falling prey to. Now, let me ask you this. Before I do that, what is the domain of just F? Think about this from negative infinity to infinity. It is a quadratic. There are no restrictions. There's no radical. There's no fraction. It is just negative infinity to infinity.
How did you do it?
Because I know what a quadratic looks like, right?
You can factor it, you square it, and you get an X.
How about the second one? How about G? What's the domain of G? No. 0 to infinity. Why? What's under the radical has to be greater than or equal to 0. Is everybody okay? All right. Now, That's the only restriction on that one, yes. Now, when I combine them, that means whatever I do, whatever operation I do, even if once I do it, my domain changes a bit, this has still got to be, like, I'm only working, if here is 0, I'm only working with this part of the number line. I can leave more stuff out once I combine it, but I'm only there right now. I cannot look at this part because initially it was not part of either one of the domains. Does that make sense? Okay, so when I multiply here, and I've just got x squared plus 9 times the square root of x. I can leave it just like that, but what is the domain of this? I can leave it like that. You don't have to do anything else with it. There's not really a lot that I could do unless I changed this to 1/2 and started adding those exponents together in
Negative
gross.
A to 0 to infinity.
That was the example that I gave you here because I said f times, yeah. What's the domain of the combined function? What's the combined domain? Got to be 0 to infinity. I've already left this out. I left it out initially, so it has to be left out in the combined one.
So you basically just take the lowest one.
Okay, yes and no, because what if I made this?
Alright, well, and that's the high one type of it.
Let me add another, let's say h of x. What's the domain of that one? It's just a line. It's just a linear function. Okay, so I'm still got the same combined domain right now, right? Even if I combine all three. What if I asked you, what is actually, let's make this fun. I really want you to see what's happening here. What's g over h? What's g divided by h?
You don't have an H.
Yes, I do.
Where?
It's square root times.
Square root of x.
Divided by.
Now, separately, right, I've got this restriction. I've still got to be bigger than 0. But now that they're put together, there's another restriction happening here. What's wrong? Look at it.
X squared on the, yeah, plus the 0.
I added another one real quick.
I don't
Sorry.
know.
X was negative 1.
That becomes
Yeah,
your
yeah.
reciprocal function.
But here, it's a rational function. But here, the bottom still can't be 0, even though initially I didn't have to account for that. Now I have to account for that here as well. So now I have to go, okay, not only have I got to be bigger than 0, but I also got to leave out what value? 1. 1 minus 1 is 0, right? I got to leave that out. So now what is my domain? I told you the combined domain is what the kicker here. That's the new stuff. What would you have to plug into x to make that 0?
Some of those classes.
Apparently we don't perfect it.
Yes.
So it is only because
I learned anything.
format the way it's like that. Because it's like that.
Let's do another one.
She said you factor all that.
Here's your reciprocal functions, Logan.
Logan is reciprocal.
Alright, thank you.
What's the domain of f? Well, you tell me, what can x not be? Look at it. Why? It'll never actually touch, but look at the equation. Algebraically, why? No, you were right, it's 0. But why? The bottom can't be 0, right? That's undefined. So if x can't be 0, how do I say that? Yeah.
0. Yeah.
Yes.
Gotta trick us.
I'm not trying to trick you.
That's what I said.
Because you can't ever divide by 0. Anytime, so you got two scenarios you're looking out for. You're looking for a radical, you're looking for a fraction. If it's a radical, this is only involving domain. Yes, yes. If you're taking a fraction, you're looking at
Okay, so that's what 0.
yes, yes. It's just you're looking at those two situations. Say that again. You won't be able to see the combined domain once you combine them because you won't see them individually anymore. It'll be a little bit harder. How about G? What's the domain? Think. You're close. Negative infinity to what?
I don't know.
-2. Because if I put -2 in here, it makes the bottom 0.
So then you're going to do a negative infinity.
It can't. So that's what I'm. So by setting it equal to 0, I'm finding out what would make that happen, and that's what I need to leave out. Okay. But wait, because we haven't combined them yet. Yes, but then there could be additional. Depending on what it looks like once I combine them. Then I have to look at the function again. Okay, so right now, if I combine these two, I know right off I'm leaving out -2 and I'm leaving out 0. Sometimes it helps me to see it on a number line. It's a little easier for me. Right? So whatever I do, right now I know those are going to be left out if I put these two together. What happens if I ask you to find f times g of x and find the combined domain? Try it on your own. Well, right now, I know that I'm leaving out -2 and 0 whenever I combine them. But then I also, once I do the operation it tells me to do, I have to look at the function that I'm left with and say, okay, are there any new things that I need to leave out? So I'm doing essentially a third function to look at once I combine them. Look at your answer to see if there's anything left out of that also. Let me show you what I'm talking about. All right. Okay, go ahead.
His name
Okay.
is Rico.
1 over x times 2 over x plus 2. Agree or disagree? Okay. So this becomes 2 over x times x plus 2. Yes? So now I need to stop. I already know that I'm leaving out -2 and 0. Yeah. I could. That's fine. But I need to look at my solution now. I need to look at my answer. I need to look at where I combine them and say, is there anything else that I need to leave out of my domain? Is there?
No.
No. Well, because I'm looking at it, if I set this to 0, that means come up, you have to also leave that out. That's correct. That's correct. So for this one, the domain is just the combined domain, which is -infinity to -2, -2 to 0, 0 to infinity. Does that make sense? No. Sometimes. That 0 because of this domain. Nobody does.
So
we're doing
basically, you
the
just
range.
put the two together.
Yes.
So wherever these come up, wherever
You do this one. We're not even doing range right now.
Well, of course.
Whatever y'all are doing, stop. Okay, it's what? Yeah. Well, this is a, use the same F and G. That's okay. You have one fraction over, but you know how to do that because we did complex fractions. What do? That's right. I've got 1 over x times x plus 2 over. Why? Who told you that nonsense? I told you we weren't doing that.
Yeah.
There's my function. Right. It's going to be the same thing. There's nothing new. As I look at this, if I set the bottom to 0, I get x equals 0. I've already left out 0. I don't have to leave it out again.
Oh, I get it.
Yes, only the denominator. Oh my goodness. You just do it. I mean, I don't know, right. You just do it. No. No.
You don't solve for the
You don't solve for the...
-2. Solve for the top. You got -2.
You have to solve for the top.
You don't have to solve for the top. You have to solve for initial equations. You have to look at the domain restrictions from the initial equations, and then you look at your combined, and you say, are there any restrictions on this one? So I'm looking at that are different. I'm looking at any restrictions on this one, but then I have to combine it with the restrictions that already existed from the original. That has no, the top has absolutely no bearing on the domain in this case. Tops do not impact.
So top is right.
Oh, because the last one on the bottom was 0 and
Right.
so it was right.
Oh, no.
No, because it said
Yes,
x,
yes,
x
yes,
plus
yes,
2,
yes,
so the x was 0.
Yes.
Yeah, so go back over that.
I told y'all this was the hard part to wrap your brain around.
This is the hard part.
Bit of radicals to show you this. This is about a third of the lesson. Huh?
We can't teach a lesson without laughing.
Why? We'll be right back. Tell me this. Yeah.
Just can we go to the Copa Band?
Superintendent cabinet thing. What's the domain on F?
0. Like -. Yep, 100%. That's right.
Say again. You're getting there. -6 what? What about -6?
Infinity. Let's go.
-6 makes it 0. That's right. What's my restriction though with radicals?
Well,
Can't be negative. So that means I need x plus 6 to be bigger than or equal to 0. Do you agree? Why? That means positive. So it means x has got to be bigger than -6. Could it be -6? Sure, you can take the square root of 0. Square root of 0 is 0, right? I just can't take the square root of -1. So if I've got to be bigger than or equal to -6, give me the domain. -6 to infinity. Everybody okay with that one? Okay, how about G? What's the domain on G? Close to infinity, because it's x minus 2 this time. Okay? Is everybody okay? That's the individual domains. Now, what happens if I said, what is this, and give me the combined domain? You know, sure you can do it.
Oh,
It's addition.
that was a good
2x plus 4.
Well, in this case, so I've got square root of x minus 2. You can't add those. You can only add like radicals, right? So I just leave it.
Equal to 0, and then 0 plus, and then
What are you talking about?
Oh, it's 2.
All right, so I'm just
Square root.
no. You can't add them. Is what I'm
Yes,
telling
you
you.
can.
No,
They're
you
like
can't.
radicals.
So then just multiply them.
What's define like radical?
They're the same radical.
They're the same root. Define
Yeah.
like radical though.
Don't
Same root,
Same thing underneath.
same number underneath.
Oh,
These are not
yeah.
like
No, they
radicals.
aren't.
Like radicals, if this was the square root of x and then 3 square root of x, I could add those to get 4 square root of x. These are not like radicals.
Can you add 8 to the other one?
No, you can't do that. You just leave it. If you can't do it, just leave it. Okay, same domain how? I haven't combined my domains though.
Negative, or then 2 brackets. Or whatever, however you would write it.
Remember, if it's not okay for one of the functions, it's not okay for the combined function.
Then 2 bracket and 2.
Negative 2 bracket.
Why? Explain it, Logan.
Because the first one, the second one can't have negative 6 or anything.
Here's negative 6. Here's 2. The first one says it has to be from here to the right. Okay, so I've left off all of this. The second one says I have to be bigger than 2. Well, if I have to be bigger than 2, I have to leave out all of this. So it's got to be from 2 to 7. What if I change?
We're not doing it. Good job. Thank you. I'm working on grades. Trying to be like you.
What's different?
Solve it.
Now I actually evaluate, right? What does that mean? I plug in a 6 for every x. Is it okay for me to use a 6 in this problem? Yes. Is 6 bigger than 2? Sure. Well, okay, why wouldn't it? What if I asked you to do this? Why can't I?
Oh, because I have to be bigger than 2.
That's not in my domain. I have to have a value in my domain. That's undefined at that point. So if I come back and do 6, I take my combined and I say the square root of 6 minus 2 plus the square root of 6. Which, yeah. Yes.
Great job, bro.
You can't because the 2. Yeah. All right, I got one more thing to show you.
Let's go. One more.
We're going to use the same process of combined domains as we do this. We have done this before, but we're adding the combined domains to it. My point is 2. 2. Do y'all remember function composition?
Oh.
For some reason,
Isn't that what we
this
just
just
did?
throws students. Okay, no. Composition. Composition is when we plug one function into the other.
Oh, is this the one where you leave the little like cleared out circle dot?
So
Because I had to do this in Math 1 too.
it could look like
Yeah, that.
this. And that's just a composition, and all that means is I take the innermost function and every x in f goes into the outermost function.
That's what I'm doing right here.
Right. All right, so let me give you an example. We're going to do the combined domain on this one too, so stay with me. This is where the domains really start to change. What? Davis has left the building. You said I've already left. I said, oh, so Davis has left the building?
Let's go.
If one of you left, I wouldn't stop you. I would just write you up. That's right.
Really?
All right.
That's a good.
Here's my two functions. As I look at these two functions, are there any domain restrictions on the first one? No, that's a linear function. What's the domain?
Everything.
What about the second one? What about G?
Yes.
What's the restriction? Can't be -1, right? So give me the domain of the second one.
-1, U, -1.
Okay. Find f of g of x in its combined domain.
Find fog?
Find fog.
Okay.
What's wrong?
Yes.
I'll go there.
All right. Since y'all are asking me, this is really f of g of x, right? I'm taking g, and for every x in f, I'm replacing it. So I get 3 minus, and it's not x anymore, it's now. We've done this before. To combine it, we need a what? The like denominator. What's the LCD here?
+1.
X plus 1. I'm sorry. That's right. So I get 3x plus 3 minus x over x plus 1. That close. 2x plus 3 over x plus 1. All right, so here's my composed function. That's my f of g of x. How about my domain? Because there's your new part, is your combined domain. It's still just -1. The denominator's the same, right? So here, the domain is what? Will I get the same thing if I transpose f and g? If I switch their places? Do we know? Try it. You find g of f of x and find its combined domain. On your mark, get set, go.
Jared, go.
3x and 1 over x minus 1 plus 3. Cancel for that.
I thought they used Alex. Talking about his math on 10 he did. All right, so I'm replacing the x's. So I got 3 minus x over 3 minus x plus 1. Agreed? Now, this one's a little bit different. Yep. No, because you'd be killing a kitten.
Yeah, die, kitten.
Shut up, Logan.
Get him.
Sorry. I got excited.
Only when you're multiplying or you have everything in parentheses. So this is a factor and this is a factor, but you can't cancel them out. Only when you're multiplying. If that had been 3x over 4x, yes, you could cancel them out. All right. So here I am. I've got my combined domain, right? This is my combined domain. Does it change whenever I change to g of f of x? Yes, I have something else I have to leave out of my domain. What's the something else I have to leave out of my domain? 4, right? Because if I plug in a 4, I'd get a 0 on the bottom, right? So now not only do I have to leave out -1, but I also have to leave out 4. So how am I going to write that? Pause. If I changed and put a number here where this x is, could you still do this? If I put a 3 where that x is, you understand that's just coming in again. Without thinking about that is a function that has already been composed. This is h of x, and h of x is f of g of x. What is f and what is g?
F is x over x is 1 minus.
That is correct. Can you see the function contained within the function? F, that's my outside function. That's what I'm plugged into, right? So what's the outside function? What's the big picture function? Something cubed. What's inside? What did I plug in? What's the g of x? I've already 1 minus 2x. 1 minus 2x. I have almost pushed you to your limit today. I see it written all over your face. We're going backwards on that composition. Now we're thinking about it as I've already plugged one into the other. What did I start with? We're not even doing domain for this. I just wanted you to see. Yeah.
You just wanted me to.
Let me show you.
When you go back, please.
So I gave you this, and I said, if this is a composed function, what is f and what is g? This, I'm telling you that h of x equals this. What could your f and what could your g be? What could you have possibly plugged in to get this? Okay, let me show you another one. No, yes, Davis, stop it. What could your F be and what could your G be?
Square root of x, or cube root of x.
That's your what?
That's one of them.
Is that your outside or your inside? Outside. I'm going to call that F. Look at you. You
I'd be fine with that.
Miguel, can you please show up? Every single day, right in here. Just for the fun. Thank you. That would be so kind of you, Miguel. And I would cheer.
Kaylin, you're on a roll.
Be like,
What's F?
Back here.
X, the outside
The big picture one.
is x. No, x, 1 over x.
That's right. These are going to be, most of the time, these are parent functions.
This is McGee.
What's your G? What's your G?
What are we
X
doing?
minus 1. No,
No.
x plus 7.
Or
My brain hurts. I don't know.
Actually,
4 over x minus 1. Yeah.
I got 1, and that's good to get. I see,
you're close.
I had that. I had the
I have a
extra 7.
question.